And today I'm going to present a demonstration of the Industry 4.0 AI strategy. Um, the demonstration is about building our MCP AI agent for Ignition platform. There are four different steps. The first to build up a virtual factory using the Ignition platform. By the way, Ignition platform is the top IIoT platform. And it's very popular, and I'm going to go through that and build our virtual factory digital twin simulations. And the second step is I'm going to expose the data, the digital twin data through the OPC UA server. That is the industry protocol, and to expose the digital twin data. The third step is to build up our MCP server using the Python and then to wrap the OPC UA server and so that the agent can access. And the fourth step is going to be demonstrate our agent uh, to go through the MCP tools to get the data and using the natural language to so that the people, field engineer can ask for the questions. This is the architecture. And inside the box, this is the typical industry IoT solution, including the different components in the center. This yellow part is the IIoT platform. This is the bridge between the OT and IT. So the OT data is sending up through the PLC and the device and then to consolidate to the IIoT. And IIoT have two different value proposition. Number one is a unified naming space, universal naming space. This naming space can really simulate the real factory, the product line, and the real use case, and to abstract all the heterogeneous realities of the OT side so that all this data will be ready for the IT to consume. And the IT side has two different use cases. One is the production pipelines, go through the ERP, have the work order, and then bring the work order to the manufacturer execution systems to start the production process. Meanwhile, have another process is called operation or the maintenance. That is enterprise asset management and a computing machine, computationalized machine maintenance service. And this one is including the predictive maintenance, equipment advisor to make sure the machine is running as usual without any problems. So there are two different use cases. But today, you know, I just focusing on the IIoT, and maybe in the next demonstrations gradually and showing the other components. So the goal for today's video is say, hey, we have these industry IoT solutions and really implement the Industry 4.0 strategy. And what is the AI, particularly generative AI, for? So today I'm going to answer these questions. The real AI is bring the natural language communication experience, and so that the personas, including the field engineer or the field managers, can communicate with the agent and send the instructions, retrieve the information from the system, particularly in this case, largely from the industry IoT platform. Go through the technology, for example, the MCP, model context protocol, which is the universal protocol agent that can access the field data and also build the agent. So my goal is to make this as simple as possible. So we on purposely select the simplest technology to articulate these solutions, but to make sure the components and architecture align to the industry IoT. Now let's take a look of steps. Step one is I provision a virtual machine on Azure. The reason is this is totally similar to the IoT Edge. This is going to be a box on the Azure so that I can install the Ignition platform and install whatever the language program or in the next videos maybe install the large language models so that make sure the agent could be the local deployment. But in this video, I'm gonna using the existing agent and then configure to showcase. And the number three is MCP server. The server is also local. It is created by the Python with the MCP server, and then being tested using the MCP inspector. And finally, get the agent on the software is called the Cherry Studio. Step by step, showcase all these four steps. First, virtual machine. We already in the virtual machine, so there is nothing much to show. I on purposely provision is pretty big, and this is the 8 CPU and get sufficient memory and storage so that in the future video I'm going to deploy the local large language model so that the agent can totally running locally. The second step is the virtual factory, and let's take a look of the ignition. Ignition could be the number one or number two industry IoT product to build the industry IoT protocol. The value proposition for the ignition platform is to the OT engineers is totally abstraction. It's get the universal naming space so that doesn't matter how heterogeneous you are for the OT side, using the different machine. Maybe some machine is 50 years old, 70 years old, and then do the transformation so that you can get the modern structure of the to simulate the factory product line or the city. So anything you can simulate. And there are two parts. One is gateway, is mostly configure the information. One is designer, and we mostly using the designer. Actually, what I show you is really the virtual factory. It's including three different containers, and then they are merged to the mixture, and using the pump to send it to the reactor. So such easy like that. The this is a for yeah, it's obviously this is the like hypothetical, it's not the real, but this can articulate. You can say, hey, you get the juice factory, you get the Coca-Cola, Pepsi-Cola, or you get some chemical factories like DuPont, Monsanto, biomedical, all those kind of things could simulate from the chemical engineering's perspective. And here, all the data is in real time. Of course, for the simulation, they are randomly generate data. I just keep later the flow is going and doing. But the key things I can turn on and turn off the pump. If I turn off the pump, and the flow is going to stop dropping because. But the reactor is going to be empty in a few minutes. But if I turn on and then it's going to resume to do the work. So this is the simulation. This is the digital twin, the digital edition of the factory. And in the real case, all we need to do is connect to the physical assets through the PLC or the device, and then to make sure the data being synced up. But now the use case is starting from the ignition. I've already built up this, and everything is simulated. Okay, I make this turn off so that it's kind of the stable and stay here. Now, based on uh, the agenda, the steps, we have the factory, and then the factory build, we need to introduce that say, hey, this is the protocol. All the data were exposed to the external world by the OPC UA. Then we go to the gateway side, and then to see the configuration is here. You can configure the server settings and server connections. And after I can configure, I do the verification. Okay, if I can access the server and Ignition itself have the quick client, and you can immediately see, hey, you get all the attacks of the factories being loaded. So which means you can connect it by themselves. But for additional safe, for the future development using the MCP, using the Python code, I have another different software. It's called a process OPC UA browser. You get the connection string and then configure. You can see complete the factory here. The factory and all these objects as I created. So which means the OPC UA server is totally available. Now we can start coding the MCP. Go back to the Python code. The Python code is very simple in here. Just of course, you need to set up the environment variables and the requirement, install the libraries, and here it is almost like a general Python code. The only difference is you need to add the MCP server fast MACP library, and in the end you need to set up the server. Let it go. There are four tools configured. Four tools configured. The first two tools is retrieve. You can of course, it's a decorated pattern. You get the tools decorated here, and then you can retrieve the tank levels, and you can retrieve the factory status, and you can retrieve the turn on the. Now this is not the retrieve. This is a send the actuation to direct the field. You need to turn on the pump and turn off the pump. So I get the four tools. You remember that so that we can examine that. And then there is a default tools is called inspector. If you started the server like this and then as an inspector and then you run this, it's automatically started the MCP server. Meanwhile, it will open to this local website. And if you do the connect, it turns to green, which means connected. And then you can go to tools and the list of the tools. You can get four different um, tools is here. So how does tools working? Because this is the MCP inspector. You just click and run the tools. You can see immediately. Tank level is going to be showing here. If we go back to here, you can see 67, 89, and 68. So this is exactly the number here. So which means it's working. And also factory status, we can directly take log, and the status is here. All these kind of and the metadata is going to be generated to the speed and the pH, temperature, pressure, and energy. Okay, and here you turn on and turn off. You can turn on and turn off, and you run this, and then you say, hey, this is turn on, and then you can turn off. Yeah, right now it's turned off. I believe it's affected. It's turned off, and if I click turn on, it's going to be turned on. Yeah, it's going to be turned on. So now, yeah, let me turn off. So this is only a testing tool, just like API testing tool, like a Postman, and it's not a real agent. How can we create an agent? It is very easy. And there are so many different tools like a Cloud Studio, and also we can use the cursor to do that. The one I really like it is called a Cherry Studio, the Cherry Studio, and let me go back and I cancel this inspector version, and then I using the Cherry Studio version and to open it. So this is the Cherry Studio version, and if I go to the settings and go to the MCP, and you can see the batch plan control, which I just created is here. And all then you need to do is configure a few fields, and then you get the connections to set up. After setup, you're ready to do the test. The good thing for the Cherry Studio is number one is very easily to set up the MCP tools. Number two is a lot of large language model for you to choose, and many of them are free. To here using the Cherry Studio and Queen Wing, which is Alibaba's, is the free. So we are using the free. Do not spend any money, and then we can test that. So how can we test that? Everything by the natural language. Can you tell me the levels of containers? Yeah, so whatever language, the large language model can understand. So yeah, it's got a tank 1, 2, and 3, and we can go back to the virtual factory 33, 55, and 34. And now we can maybe say, hey, the currently, and also tell me the status of the factory system. And then it will come say, okay, the pump is on and the valve is closed, and the tank is like that, and also tell me the the current of current. Yeah. Okay. And now, we can do the actuation, please. Let me see the current status of the the pump is on. Please turn on the pump. Yeah, the pump is on, and we can see that the pump is on and it's all running. And please turn off the pump. Okay, the off. So the showcase is over. Let's go back to the original agenda and take a look, what we have prepared. So and we tested the agent. So what is the next step? It's going to be very interesting. And what I think is the next step, maybe is before the large language model local deployment, we need to get a history data and database data. So the reason is the showcase we're showing is the OPC UA of the real-time data, right? What is exactly happening now and turn on and turn off? That's not enough. We need to get the historic data for the device, and so that we can do the real analyze and generate the dashboards and generate the analytics, right? And also we need to reach out to the database for the ignition and for a lot of configurations there so that we can do the analytics. This is going to be the big steps. And after that, what I'm thinking is the reason I provision the virtual machine relatively big is I'm going to local deploy the large language model because many industry use cases that they are have the much more strict demandings on the security. They don't want to disclosure the data, and then the local model and the MAR ops is going to be the important. And the third, the third thing that for the next video is going to be the agentic solutions with land graph. So far, I just created the one agent and using the Cherry Studio. That is out of box and depending on the tools. I need to using the land graph and to create with the Python and create the agentic solutions with the multiple agents, and so that really get the like automation and human intervention like harmonized to be the one picture. And then number four, we can implement the voice interface. So these four is the to-do list for the next demonstrations. And thank you for very much for your attention on this Industry 4.0 slash Industry IoT AI enablement. Specifically is the AI Agentic Solutions Enablement Series. This is the first one, and look forward for the second one.